Hi, hello, welcome to Intermediate Studies. In today's video, we are going to cover some of the most important 2 mark questions from Unit 4 Motion in a Plane in Intermediate First Year Physics. These questions are frequently asked in exams and are key to scoring well in the very short answer section. We are also explain each question with simple examples to make your understanding crystal clear. So stay tuned till the end. Let's get started. Yeah, here is the first question. What is the vertical component of a vector is equal to the horizontal component? What is the angle made by the vector with x-axis? Remember, vector with x-axis they are asking. So this is the x-axis and this is the vector and this is the y-axis. So they are asking the angle made with the vector with x-axis. So that's the reason we are taking the angle here with the value of theta. So and they are saying vertical component of vector is equal to the horizontal component. Here the vertical component is f sin theta and horizontal component is f cos theta. Just equal these two values. F cos theta is equals to f sin theta. So finally f gets cancelled and the theta is equals to 1. We obviously know tan 45 is equals to 1. So simply tan theta is equal to tan inverse of 1, which is equals to 45 degrees. And finally the angle made by the vector with x-axis is 45 degrees. Simple. The next question. A is equals to I plus j. What is the angle between the vector and the x-axis? Same question. Here also, if you take the diagram here, this is the x-axis and this is some random vector which is they have already mentioned a is equals to some I plus j, and here this is the x-axis and here this is the y-axis, no need to mention, and here we need to calculate the angle between the you can write. Yeah, here they're asking the angle between the vector and the x-axis. If you see here, the vector a is equals to I bar plus j bar. If you see na here, the magnitude of the vector I and the magnitude of the vector j is both are same, 1 1. The magnitude of the vertical component and the horizontal component is same. If you see, these two questions are same only. Here in question they described like the vertical component of vector is equal to the horizontal component, but whereas in this question they are given the statement with the value of a is equals to I plus j, which means the both vertical component and the horizontal component, the magnitude of vertical component and horizontal component are same. So if you consider the cos theta is equals to ax by det a, sorry, magnitude of a. So finally what is the ax, which means the what is the magnitude of the uh, magnitude of the horizontal component is 1, right? So ax is 1, so 1 by what is the magnitude of a, root of a square plus b square, which is equals to 1 by root 2. So where we get the 1 by root 2 in cos, it's 45 degrees. So finally theta is equals to 45 degrees. Next, third question. Two forces of magnitude 3 units and 5 units act at 60 units with each other. What is the magnitude of the resultant? Resultant is nothing but r. So this is the formula that you need to remember to answer this question. So resultant r is equals to root of p square plus q square plus 2pq cos theta. What is the value of p is 3 units. What is the value of q? 5 units. And what is the theta? They have given 60 degrees. So finally substitute all the values like 3 square plus 5 square plus 2 into 3 into 5 into cos theta is 60. So cos 60 is 1 by 2. Just substitute all the values and calculate, and finally root 49, which is the square root of 7. So so here if you see, they have given the units called units. They haven't mentioned like any centimeters or anything. They have given like 3 units. So that's the reason you have to in the answer also you need to mention that the same units as units. So or else you will definitely deduct 1 mark. So don't skip the units. Just definitely you need to write the formula, and you need to get the correct answer, and you need to give the units for that answer also. The next question. when two right angle vectors of magnitude 7 units and 24 units combine, what is the magnitude of the resultant? Right angled vectors means what? This one, right? For right angled, we know the theta is 90 degrees. So uh, theta is there 90 degrees. So theta is there, and p value is there, and q value is there. We already know the formula. R is equals to root of p square plus q square plus 2pq cos theta. So but you have to write this formula in your examination and finally substitute all those values and calculate, and you will get root 625, that are 25 units. That's it, very simple. Both are same, only just values are different, and they given the angle like right angled, which means 90 degrees. Just remember that. So next question. Next question is, if P is equals to 2i plus 4j plus 14k and Q is equals to 4i bar plus 4j plus 10k, find the magnitude of P plus Q. So they are asking to calculate the magnitude of P plus Q. So first calculate the value for P plus Q. Just simply add these two vectors. 2i plus 4i is 6i, and 4j plus 4j is 8j, and 14k plus 10k is 24k. So first add up those two vectors, with means p plus q, and now we are used to calculate the magnitude of that p plus q. So what is the formula for magnitude of p plus q? Is a root of a square plus b square plus c square. Just we need to take the magnitudes of those vectors, and we need to square those under the root. So see, root of a square plus b square plus c square means 6 square plus 8 square plus 24 square, which is finally we are getting 676. So the answer is 26. And next, what is the acceleration of a projectile at the top of its trajectory? So the acceleration of the projectile at the top of its trajectory is g, and it's vertically downwards. So for g you will get 1 mark, and for writing vertically downwards you will get 1 mark. If you skip g, or if you skip this vertically downwards, so definitely you will lose 1 point. So you have to define like the acceleration is g and it acts vertically downwards. So the next question. Can a vector of magnitude 0 have non-zero components? No, definitely no. Because here, see here, can a vector of magnitude of 0, which means the magnitude of 0 vector, we will only we will get the magnitude of 0 when we take the 0 components. With non-zero components, we won't get the 0 magnitude vector, right? So if we have 0 components, then we will get 0 magnitude vector, but with non-zero components we will not get that 0 magnitude vector. See the reason. No, a vector with 0 magnitude cannot have non-zero components, because magnitude of the given vector, this is the formula for magnitude of the vector, right? V is equals to root of vx square plus vy square, must be 0. This is possible only when vx square and vy square are 0. When the when the components are 0, then only we will get the 0 vector magnitude. That we need to give the reason here. Yeah, that's all for today's video on motion in a plane, important 2 mark questions. If you found this helpful, don't forget to like, share and subscribe to Intermediate Studies for more exam focused content. Drop a comment if you have any doubts or want us to cover a specific topic. All the best, students. Keep learning and keep scoring. Bye bye. Thanks for watching.